Right, so let's look at how to deal with a separable differential equation when we're given an initial condition. So these are initial value problems. And we're going to start this out the same way that we were solving the other ones. We'll start by getting our general solution. So dy dx is equal to negative x over y. So I'm going to multiply this y over. So I have the y and the dy together. And then I will multiply the dx back to this side. Okay, so I have my y dy is together, my x dx is together. So I'm ready to integrate both sides. This gives me y squared over 2 equals negative x squared over 2 plus Charlie. So I have a general solution here. And now I'm ready to look at these initial conditions. So I know that y of 4 is equal to negative 3. So that means when x is 4, y equals negative 3. And I'm going to plug these values in and then solve for c. I have negative 3 squared over 2 is equal to negative of the quantity 4 squared over 2 plus Charlie. So 9 halves is equal to negative 16 halves plus Charlie. I'm going to add the 16 halves over to the other side, so that tells me that Charlie is equal to 25 halves. And I'm going to go ahead and plug that in so I can get my final answer here. So I have y squared over 2 plus x squared over 2 equals 25 over 2. Let's see if you recognize what this solution is. This is x squared plus y squared equals 25. So that is a circle. So our solution here is a circle. All right, and then let's look at number 11. So I have dp dt is equal to 2p minus 2pt. All right, so I need some function that just has p in it times another function that just has t in it. So to get that, what I'm going to do is I'm going to factor the p out. So I get 2 minus 2t here is dp dt. Okay, and then I'm going to divide this p over. So I get 1 over p dp is equal to 2 minus 2t dt. So it looks like I have everything with the p on one side, everything with the t on the other. I'm ready to integrate. So 1 over p, that's going to be natural log of p. And then this is going to give me, I'll do term by term, so I get 2t minus 2 times t squared over 2 plus Charlie. Okay. And let's see, I want to go ahead and solve for p here because I think that's actually going to help me when I apply my initial conditions. So I'm going to take e of both sides. So remember that e and natural log are inverse functions. So if I do e of both sides, the e and the natural log are just going to give me a p back. So I get p is equal to e to the 2t minus t squared plus Charlie. I'm going to clean this up a little bit further. So I have e to the 2t minus t squared times e to the Charlie. And what I'm going to do is I'm going to call this e to the Charlie. I'm just going to call that a capital letter B. So that means now my solution looks like p is equal to b times e to the 2t minus t squared. All right, so this is one of those things I was talking about in one of the earlier videos where we get kind of a bunch of wonky constants all over the place in differential equations, and so we kind of just sometimes sum them up under one big capital letter. All right, so let's apply our initial conditions. So I have p is equal to 5, t is equal to 0. So I get 5 is equal to b, e to the 2 times 0 minus 0 squared. Okay, so this is e to the 0. Remember, anything raised to the 0 power is 1. So I get 5 is equal to b times 1, or just basically b. So b is 5. Now I can update my solution. So the exact solution using this initial condition is p is equal to 5 e to the 2t minus t squared.